This problem is asking us what are all the horizontal asymptotes of this given equation over here. And you heard me emphasize that word all the horizontal asymptotes. I say that because you always have to go looking for two horizontal asymptotes. There's always two places that you potentially could have a horizontal asymptote at, and they are not always the same. And most people think they are. So when they do it, most people remember to do it the first way, which is finding the limit as x approaches infinity. Whenever you want to find a horizontal asymptote, it's always limit as x approaches infinity of your f of x, and then your answer out here, that's your horizontal asymptote, whatever that y value is you're headed towards. That's the one most people remember. But when you're finding horizontal asymptotes, it's the long-term behavior, and it's the long-term behavior in both directions. So you also need to look at this as far as x is headed to negative infinity. And then whatever you get out of there, whatever that y value is, that would be another horizontal asymptote. So to find horizontal asymptotes, if they just say the word horizontal asymptote, that means you have to do both of these. Limit as x approaches infinity and limit as x approaches negative infinity. These answers are not always the same, so keep track of that. We now go to doing this actual problem here. So we go to our equation that they gave us, and we need to do these two different problems here. So the first time through, we need to do the limit as x is heading to positive infinity of 7 plus e to the x over 1 minus e to the x. When you're doing limits at infinity, what you're looking for here is what's known as the dominant term. That's what I call it, at least. You're looking for the term that is going to lead the behavior of this, is going to get big fastest. Most of the time you're doing a problem like this and you would use the highest power of x. And in this problem, you can see you don't have powers of x. What you've got going on is an exponential function. Really, anytime you're looking at e to the x or 5 to the x, something raised to the x power, that's an exponential function. Exponential functions are always going to win as you head off to positive infinity, because those graphs, what they want you to know about those graphs, those graphs are headed up and always doing something like this. So as I'm headed off towards positive infinity here, you can see that my graph is headed up and it's getting big heading towards infinity. The other thing that you would want to know about these is sort of there's three options on how the limited infinity can work. And so we talk through them real quick to be able to find out our answer in a hurry. So option one is what I would call a top-heavy situation. So if your dominant term is only on the top of your fraction, so if you only have it going on up top, then what's going on the bottom doesn't really matter. So the top-heavy situation is growing out of control. It's heading to positive infinity, and there's nothing the bottom can do to stop it. So this thing would head to positive infinity, and you would have no horizontal asymptote, no HA on that. Then looking at option two in these situations is the reverse of that. It's what I would call bottom heavy. And so in that scenario, you could have something on top, but the bottom is where the winner exists, and it only exists on bottom. So that's like having 1 divided by infinity, this huge number. So that would be a decimal point with a bunch of zeros. The answer on any bottom heavy is y equals 0. That is your horizontal asymptote on any bottom heavy situation. And then the third option that you go looking at would be option 3, where these things are balanced, where there's equal dominant terms on top and bottom. So those two equations are growing at the same pace, but what matters now is the coefficients in front of them. So if you add 5 times this and 3 times that, the coefficients end up being your answer as you go through this. And so when you do these problems, you just have to be careful about which direction that you're heading, and then you need to know whether it's top, bottom, or balanced. In this problem, we are looking at x heading to infinity. And as we come through to find our dominant terms, what we see is e to the x, that's just one of those graphs they want you to know, right? E to the x is an exponential graph. It's going up like this. So, oops, that's e to the x. And so what we know about this is as x heads out in this direction to positive infinity, our graph is growing and growing and growing. That thing is headed up to infinity. So this piece is headed to infinity. 7 is going to just be headed to 7. So on top right now, what we have is the dominant term is e to the x. On the bottom, as we look at this is e to the x again. As x gets bigger and heads to infinity, this thing's going up to infinity. And then 7 is just going to, or excuse me, 1 this time is just going to be chilling at 1. So infinity is going to beat out 1 every single time. And so on the bottom, what we have is not just x, but we have negative e to the x. So what we're looking at here is option 3. We have a balanced scenario. And you can kind of see why. These things essentially cancel each other out. You've got a 1 over negative 1. So then negative 1, y equals negative 1, is one of your horizontal asymptotes. So you at least know it's not that one, and you know it's not that one because it has to have negative 1. So we've narrowed it down to those options. And from here, you have to come back and remind yourself that you also need to go in the second direction. You need to know what is happening, limit as x approaches negative infinity of this same equation. When you're dealing with exponential functions, you got to be super careful because as they head to infinity, they get bigger like we keep talking about. So as they head off to infinity, these things are getting larger and larger. They're going up that way. But as we head backwards towards negative infinity, in this situation, what you'll see is you're headed this way, as x is headed to negative infinity. These values are actually going down. This thing is headed to 0 in this direction. So looking at our dominant terms, e to the x is actually headed to 0 as we go to negative infinity, and 7 is going to 7. So 7 is going to beat a 0. 7 is more dominant than a 0. 7 sticks around and 0 goes away. And on the bottom, same idea here. E to the x is headed to 0. I don't care if it's a minus 0 or not. And then from there, that's a 1. So this would be 7 over, and the dominant term on bottom would be 1. And so out of there we have 7. Y equals 7 would be our other horizontal asymptote. So the only one that includes negative 1 and 7 is option D right here. So just keep in mind as you're doing horizontal asymptotes, when they ask for horizontal asymptotes, you have to look in both directions, as x heads to positive infinity and x heads to negative infinity. And then there are a handful of graphs like e to the x that they just want you to know and recognize. And you have to know what their behaviors are in both directions. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.